Hello everyone, this is Esraa Altwassi from Okan University. Today we will talk about the virtual solar analysis application of immersive environment to determine the building orientation in order to achieve energy efficiency and sustainable design. First of all, VR has emerged as a promising digital technology aiming to provide architects and builders with better ways to imagine and visualize buildings. But the question is now, what is virtual reality? The person becomes a part of the virtual world or is immersed within this environment, and whilst there is able to manipulate projects or perform a series of actions, VR can be described as the simulation of a real-world environment generated through computer software and experienced by the user through a human-machine interface. Frank Lloyd Wright has described the VR, the only photograph that can be made of architecture is a three-dimensional. And to mention in this presentation, we will address the main rule for the VR in solving the traditional challenge that face designers while trying to make decisions towards achieving maximum energy efficiency for the built environment. Sustainability in the building industry. Sustainability has become an important subject because of the increasing rate of construction, which is expected to increase by fivefold by 2060. This means that global energy consumption would have similarly increased by the threefold in the same period. Actually, there is pollution prevention and improved indoor air quality, including harmonizing with the environment. Why the building industry? So the question now, why we choose the building industry? It remains one of the most resources intensive sectors globally. In contrast with other activities, the industry is a huge consumption of energy and the use of fossil or fuel. So it has been considered orientation as one of the most important parameters that have an impact on passive solar efficiency. It's also argued that building orientation, when maximized, can generate energy saving up to 36%. In this presentation, I tried to develop an innovative solar analytic approach using virtual reality technology to help building designers, architects, or system engineers and interior designers to determine the best orientation for building in order to achieve the maximum energy efficiency. So the question is, how I did it? First of all, the experiment serves the purpose of understanding how participants are likely to experience, perceive, and think of the whole process by understanding their views through how they feel heat, cold, approach of VR in housing while being immersed inside it and have the chance to change the house orientation. The experiment was followed by an interview process of data collection which aimed to collect and sample the opinion of all participants who were represented, participants' details, and presented in the following table, as you can see. For the purpose of the experiment, VR devices with embedded software was provided to participants to achieve full experience. There were two major inputs, such as the HTC Vive headset and the Tesla suit, and there was the software as well. The hardware utilized was the HTC Vive, as I mentioned, and the Tesla suit. In addition to Tesla suit, for feeling the temperature while the housing orientation was changing. A typical family house that measured around 860 square feet was used in order to fully mimic how participants live in real life. The house consists of one living room, one bathroom, one bedroom, and toilet. The experiment made use of an Autodesk Revit for the house model and analyzed for solar performance using Autodesk Insight software. So the experiment was divided into three aspects that measured participants' sensitivity to a temperature, light, and touch. Different areas of the house are expected to generate different sensitivity results, such as heat and cold, according to participants' movement around the house within the VR environment, which they can view from their headset. Lighting sensitivity are determined by spatial resolution of natural sunlight that passes through windows and openings. To analyze findings from the interview data collection, which was collected from 6 participants whose experiences and encounter with the digital VR immersion were examined according to the 3 areas of sensitivity to the body suit. And the questions asked are presented under the following table. As you can see, there were 3 questions actually. Participants encountered different feelings from the VR experiment based on their individual encounters and experience and how they experienced the experiment. Accordingly, changes in temperature were reported based on sensitivity to movement within the VR. Secondly, this reveals that there is sensitivity to temperature depending on the degree of solar availability, thus minimizing reliance on artificial light sources. Some virtual reality programs permit users to experience various light cycles, reviewing design through different duration of the day, letting the architect modify the cost of cooling, heating, and building, or to maximize the property's solar system by testing the orientation of the property. Finally, the scope of colors utilized was for reasons associated with performance, as it assisted participants to evaluate the amount of natural light the building will receive. And some points to discuss. This study has shown the potential contributions of VR in achieving building sustainability through the reduction of energy consumption by controlling building orientation. And through our discussion, while VR has numerous challenges as shown in the result, it appears that it has many advantages compared to other techniques of measuring energy performance. Traditional techniques of modeling tend to put irrelevant restrictions on design and designers and architects. VR particularly tend to be user-focused, as it accounts for the environmental elements that change during various phases of the year. And the last thing, that reduce the need for unnatural lights through the help of VR. This will result in a far more energy efficiency result. In this light, it can be concluded that VR technology can help architects, builders, and end users imagine better way for sustainable building. However, there remain challenges that will have to be solved and addressed. Through the insight gained from the research, VR arguably has a lot of potential as a viable option for visualizing and improving building sustainability. Thank you very much. I hope that you enjoy it.